Today, I'm very excited to talk to you about the intersection of behavior neuroscience and artificial intelligence. I'm going to walk you through how I've been using a tool called IntegraPose, which is the logo that you see on the right, and how it's been able to help me to move beyond just tracking the animals and to really start to put some of the questions into perspective and ask certain deeper questions. Before I dive into the technical details, I want to start with the big picture. In the field of ethology and behavior neuroscience, we often have separate tools for pose estimation and tools for behavior classification. Regardless of that, you guys know that data from the pose estimation can be put into behavior classifiers, and one can easily get some sort of an understanding of which behaviors are happening. Now, the new kids on the block are Behavior Atlas and Social Behavior Atlas. Now, this does multiple animal tracking and 3D pose estimations, much more powerful than the previous Behavior Atlas. And Integra Pose is also relatively new. This builds up off on YOLO and the Ultralytics library in Python and takes full advantage of Pythonic ecosystem. So highly customizable and things can be done with it. But overall, they all give you similar outcomes, which intermediary data sets include pose estimation. So you can take that pose estimation and do whatever you like with it. The real goal, I believe, for all of these pipelines is to have a unified system where one can do pose estimation and behavior classification. And that's the technical niche that I'm going to be highlighting here. So what does this integrated approach of Integra Pose allow me to do scientifically? I'm going to be talking about this from my perspective. Please feel free to share your perspectives down in the comments. I would love to know more about those. Now, the Integra Pose, it lets me build hierarchy of questions, and some of those questions I've brought with me here on the right side. So let me walk you through this. I can start with fundamental pose and gait analysis, and you can do this with any kind of tracking data. You can track body parts through Sleap, Deep Lab Cut, Animal Behavior Atlas, whatever your platform is, you can use that to track different body parts and then create tracklets over time to then be able to ask a certain validation or baseline validation questions, such as are the calculated speeds and posture metrics within expected range of an animal. Once you have a bunch of these for different animals, you can then start to do comparative analyses. And then there are a few questions that I've brought for those comparative analyses. For sake of time, I'm going to just ask you guys take a screenshot and go over these in your own time. I can then dig even deeper into kinematic signatures of animals and certain behaviors, of course. This lets me test or ask rather specific questions, like whether a certain mouse strain has a significantly different stride length or coordination pattern is different between one group of experimental mice versus another. Moving on from that, I can also do it with IntegraPose. This is quite easy to do with IntegraPose. It's to understand decision dynamics. For certain behaviors that IntegraPose tracks, it can give me a way to very easily identify where the transitions are happening because each frame has a behavior label associated with it. So by looking at a list of behaviors, column of behavior in Excel, I can very easily sort the column by frame number and then look at 30 or 20 or 15 frames before a transition happens and 15 or 20 frames after the transition happens, extract the postures directly from those frames alone and be able to tell if there are kinematic signatures or rather postural signatures that hint towards a change in behavior. And not to mention, if you're applying Granger causality type of an analysis here, you can start to predict whether some behavior is going to follow repeatedly uh, by looking at certain tells of the animal in the decision dynamics. Excuse me. So moving on from this, these are certain things that become easier to do with IntegraPose, but they're not necessarily exclusive to IntegraPose. But I've been using IntegraPose to do these type of things, and in a future video, I'm going to show you exactly how to do this. I can also look at causal network analysis. Now, what do I mean by this? Convergent cross mapping is one of the ways that you can identify if there are causal links between to time series data. Time series data, think of paw, right paw, and the rear paw, front paw. These are all key points that are tracked over time. So therefore, they are a time series data. Therefore, you can use those to not only do causal relationship analysis, but move beyond just certain correlations, because correlations alone may not reveal dependencies of certain variables on each other. So by doing a convergent cross mapping, and I will go more into theory in a different video, here I'm giving you guys a broader picture of how you can think about using IntegraPose, what type of questions you may want to answer. And again, many of these things are not exclusive to IntegraPose. It's just some tool that I'm using right now. So moving beyond just the concepts, let's talk about the YOLO architecture, which IntegraPose is built on, and how you can customize the architecture itself to maximize the benefits that you get out from a model that you can customize. So let's start with the backbone. I like to think of the backbone of the model as the visual cortex. Its job is feature extraction. When it looks at the image of a mouse, like right here, you see, it's not yet thinking about the mouse. It's breaking the image down. It's breaking the image down into most fundamental components, the edges, the textures, patterns, and outlines that make up the scene. It learned the visual representation, or rather a visual vocabulary, if you must. It needs those things to start to build the concept of, hey, there's a mouse here in this image. So it does that by breaking the image up into different chunks. You can have many different varieties of schemes that you can use for chunking your image, but the underlining concept is that you extract certain features from your images that the backbone is very capable of doing. So then from there on, next up is the neck, which handles feature fusion. If the backbone is the visual cortex, the neck is like the brain's integrating system, such as striatum. It takes all those simple features that are coming from the backbone and puts them all together, fuses them into combined representation, pulling information from across the entire frame to build a rich, more context understanding of the scene. So how do I build a better backbone for my experiments? I have a whole toolkit to allow me to do this. So let me go over and go over back to another PowerPoint. So I have a whole toolkit of modules that are available for you guys to swap in. Here are a few examples. If I need, for example, real-time feedback for closed loop systems, then I like to go with the C2F block in the backbone. With the C2F block, I get balance of accuracy and speed. However, if I'm looking for partially hidden animals, or there are animals that like to burrow themselves, I will go with C3X module. It has a great bigger receptive field. It's able to it allows me to look for occlusions. So bigger receptive field means you're chunking the image into bigger sizes. So uh, per chunk you will have more information in the more information to extract features from, and by having a greater area you have more contextual information, so allows better extraction of features in the backbone. If I need my model to be context aware of, for example, let's say I'm doing multiple animal experiments, multi-animal scenarios, and in those scenarios, I need my model to be aware of the positioning of animals relative to each other, because many behaviors you can infer the behavior by the position of the animal. For example, mating. There has to be some way for the model to learn that, hey, this posture or this posture of the two animals is a mating behavior. So by putting in context aware or spatially aware modules like C2PSA, I can very easily achieve those spatially aware models. Moving beyond that, for the neck, Elon is something that I like to use myself. its multi-branch fusion stabilizes many features that are uh, too coarse or too random sometimes, too messy, for example. And I like to use these in cages that are messy. For example, if I'm doing home cage recordings for animals in my experiments for mice, and they like to burrow themselves under each other or under the bedding, that gets really, really messy and very hard for tracking to take place. So in those cases, the module Elon helps out quite a lot. I'm not going to go into too many technical details, but do some Googling, figure out what kind of modules you're looking for, what type of a visual clutter that you may have in your visual receptive field, and then pick the best modules that work for you. So on that note, let me go over to my Visual Studio Code and I will walk you through an example of, uh, of making the changes that are required to get a custom model set up. So before you do anything, you must set up a YML file. You're going to pass this YML file to Ultralytics. You can obtain an example, a template of the backbone, the neck, and the head from IntegraPose. I have created a user guide for you guys. So going over to the user guide and scrolling down to model customization down here, you will have a template right here. So if you take this template, you can you can start to build your own custom YOLO models. I'm giving you guys two examples here with the backbone. Here's one example that is not commented out. Here's an example that is commented out. You need to have backbone like this uncommented so that the Ultralytics library will know which modules you're using for the backbone. And same thing for the head. Here I'm using the pose head, which is a multitask head. Here it's doing the feature extraction and object identification, and also doing key point estimation. But there's an example over here putting it all together. I'm going to go over this example in this video as well. So stay tuned if you want to learn how you can customize a YOLO model yourself. So from the top here, NC stands for number of classes. These are, in my case, the number of behaviors I'm going to be tracking, or in this case, identifying in the frames that I'm going to pass the model. Next up is the key point shape. Here I'm telling it that I have 12 key points with 3 dimensions. Those 3 dimensions are X, Y, and the visibility flag. Next up is the scales. This just tells Ultralytics what scale to build the model at. Do I want it to be a large model? Do I want it to be extra large, nano size, whatever size is best for your CPU, GPU, or your runtime? Make sure you pick that and move that one up to the first line. Then moving on to the backbone. Backbone structure is defined right here. Again, you have ability to customize it, but I would suggest you not make it too many layers. Otherwise, you will have a hard time running it on a standard GPU. So here, let's go over this. I am using C3K2 for feature extraction, then C2PSA for making my model more context aware and really being able to extract much more granular detail from down the layers in the backbone. Then SPPF is here to do feature fusion, and then C3TR is here to become context aware. This is a transformer module. It's going to learn relationships between different features of the image and how they are related to each other in the context of the image. This can be very, very powerful in social behavior settings. I'm going to first build a backbone with this, and then the head is going to be like that, with the pose head being the multitask head. Okay, you can add in another head, but computationally that gets very, very, very expensive and takes a long time to train the model. So let's get going. I'm going to open up my Anaconda. I'm navigating over at this point to the directory where I have my YML file stored. And to build the model, I have chosen the pose head right here. So I'm going to go ahead and type in YOLO pose train, and then model is going to be the name of the file, this YML file. The data is going to be the dataset.yml. Dataset, if you are doing labeling of your training dataset in IntegraPose using the graphic user interface to do annotations, then at the end of tab number 1 in the IntegraPose graphic user interface, you will have the ability to generate this dataset file. This dataset file will contain the path to different training and validation folders. It will have the number of classes that you're using for your behaviors and the names of those behaviors, something like this. So make sure that you provide that in for the data. And a couple of extra things. I'm going to go ahead and do epochs of 1. I'm not going to let the training continue. I'm going to stop it right after it prints out the model that it's going to build. And the goal of this video is just to show you how you can customize your models. I'm not showing you how you can train a full stack model. All right, so I just terminated that. Let's see. So on the right is the backbone that I passed it in. So let's look at this. So starting with number 10, so starting with the right here, I have C3TR block, which is correct. I have SPPF for fusion and S2, C2PSA right here for number 7. That's also correct. So overall, seems like the backbone is created correctly, and I know for a fact the pose head is being used, and that is all correct as well. Now moving on from here, if I want to change a backbone structure to, for example, this one, like this, I can very easily just comment out the top one and use the C2PSA here to make my model context aware, feature context aware. Over here I was making my model globally context aware of relationships by using the transformer module. So how features are arranged relative to each other, and also what features are where in the context of the image. Here, this is a spatially aware uh, module. Here, you can make your key points even you can make the model aware of your key points as well. So for certain behaviors, key point placement is extremely important, and you can make your model aware of those key point placements, because certain key point placements might differentiate the posture even if it's the same posture in the same behavior and different behaviors. Anyways, I'll play around with this. You will get the hang of this very easily. Okay, so a couple of things I'm doing here in this backbone is that I am using A2C2F, and you can obviously take a screenshot and use these for yourself and try them out on your own. Here I'm going to pass in the same command as I did for the other one. And this time it's going to build for number 10, starting with number 10. Instead of the C3TR, I have C2PSA here now. I'm also using the A2C2F. These are again these modules, the A2C2F. These are attention modules. They were introduced in the latest version of the YOLO. That is the version 12. So that's it for this video. That's all I wanted to show you, that you have the ability to customize your YOLO models and to use them for your specific needs. So takeaway, if you can, anything take away from this is that customizing the model is a simple task. It requires a little bit of upfront research on your part to figure out which modules are the best for the specific scientific question that you're asking. But after that point, once you get a hang of this and perhaps even make a list of all the modules that you might want to come back to later, once you have a toolkit for yourself, it will make your life very, very easy. You can also create your own custom modules to add into the backbone or into the neck or into the head. I've done that many times for different behavior experiments. Some behavior experiments, they require me to add in another separate offset head for temporal behavior analysis, right? So I can do pose estimation behavior classification, but if I want that temporally driven behavior analysis, then I'll add in another head to offset the temporal dimension. Point here is swap out your modules to the best of your abilities for the scientific questions that you have to build end-to-end analysis pipelines with deep learning model like YOLO. I found that the Integra pose gives me the ability to not just track behaviors, but truly to interrogate the behaviors that I'm interested in specifically. And by building different backbones and the head structures myself, it gives me the flexibility to basically analyze the type of minute or macro behaviors that I might be interested in. And that's it for this video. Thank you so much. If I've left anything out, please let me know in the comments. If you have any suggestions on certain modules that you like to use, please let me know and the rest of the community know down below so that we can all benefit from your collective knowledge. Thank you so much. Bye bye.